Hi, I'm Callista Redmond, CEO of RISC-V International, and I'm thrilled to be with you here today to share with you a little bit about the progress that we're making in RISC-V across the industry and how we're really spurring innovation and freedom of design, leveraging the standard of the RISC-V instruction set architecture. Thanks so much for joining me. You know, underpinning most of the great innovations of our time, the advancements in technology, is the element of collaboration. Collaboration using a common set of building blocks, and that's where RISC-V comes in. RISC-V is a hardware standard. It is a standard so much like USB or Ethernet or HTTP in the web domain. These are things that are important for us to all leverage so that we have interoperability around the world, freedom of supply chain, and lack of vendor lock-in. By creating standards, we share in the collective investment around ecosystems, around technology. It opens doors around the world to development partners, supply chain, as well as markets. These are critical as we continue to advance the state of the art and apply our precious resources on that differentiation and that competitive value. The definition of open computing truly is RISC-V. We see that RISC-V is absolutely inevitable. It is already prolific around the world with more than 13 billion, I know the chart says 10, but more than 13 billion cores already shipped. And we're hearing about more and more every day. Being a global standard, we don't have necessarily licensing agreements with every one of our implementers. That's why we can only estimate and rely on analyst forecasts, which to date have proven to be true. And in many cases, they're increasing their adoption numbers. This is going across all kinds of workloads, from the very low power embedded space all the way up to high performance computing and hundreds of cores. This shared investment, this collective investment on a common platform, on a shared hardware standard, is really spurring that ecosystem. It's inevitable because no one wants to create their own ecosystem around their own instruction set architecture. We'd rather have that collective investment that spurs growth around the world. RISC-V enables the best processors. This is by design. We've taken a very modular approach and have given inherent and sustainable performance as well as energy efficiency advantages that are in the architecture language itself. This enables us to focus on specific workloads and specific custom compute implementations. This ability to customize means freedom of design, freedom to innovate, freedom to take workload challenges and bring it down into the instruction set architecture, into the chip design itself. Now, RISC-V is not that implementation. RISC-V is simply the language between the software telling the hardware how to tackle that workload challenge. Finally, we're building the strongest ecosystem. It's similar to what you've seen in open source software. In fact, we work very closely with the open software space. We instrument things and then upload them into the ecosystem of existing applications, open source software, operating system, tools, and other resources. This collective investment, hundreds of thousands of engineers around the world, is really instrumenting the future based on RISC-V. The numbers really speak for themselves. We've seen more than 4,300 RISC-V members. That is encapsulating more than 21,000 engineers around the world, just in our membership and in our own ecosystem here. You don't even need to be a member to implement on RISC-V. Anyone can leverage that standard. Similar to Ethernet, anyone can use that standard. Similar to Bluetooth, anyone can use that standard. That's what we're doing in RISC-V. We're continuing to see this monumental growth around the world, and we're so proud of that. In fact, what we see today is about a third of our members in North America, a third in Europe, and a third in APAC. This means that Globally, you have opportunity to engage with others in this important space. The latest numbers from November are showing that there's going to be more than 16 billion SoCs. Those aren't cores. Cores is even a multiple above that by 2030. This rapid growth is something that we're seeing across many different workloads. Let's look at what some of those workloads really are. So we see this in wearables, in compute implementations such as notebooks and servers. We see this in communications, 5G infrastructure, as well as mobile. We're seeing this in AI acceleration, where you're augmenting existing workloads to accelerate or extrapolate more value. This is the element of innovation. This is where our community and our industry is really seeing opportunity for innovation. We see this in public infrastructure, such as smart grid. We see this in automotive, such as AI and acceleration there as well. These figures by 2030, roughly about a quarter of each of these markets is going to be running on RISC-V. You know, a few years ago, I asked an analyst, how about, and he put out a report about how many design starts are on RISC-V today. And he studied this space and came back with nearly a quarter of design starts a few years ago included RISC-V in at least one core. I asked him last summer, how are we looking? What are these numbers like today? He said, it's actually very hard to find a design start that does not include RISC-V. This means RISC-V is becoming a pervasive piece of implementations around the world and in various types of workloads. Let's think more about these workloads. So that revenue, the translation between those 16 billion SoCs, that's volume. What does the revenue look like? It's growing very fast. And I understand off a small base, these numbers look very wild. However, let's just think about the raw numbers themselves. 6.1 billion in 2023, growing to 92.7 billion by 2030. This is massive growth. This is a massive market opportunity. We're seeing this predominantly in compute and consumer, followed by automotive and industrial. And of course, you see different types of hybrid workloads within this particular span. In IoT in particular, we're seeing a lot of growth. We see this in, the overall market of IoT is growing, and the proportion of that is RISC-V is growing most exponentially from 2022 onward. We're seeing this in consumer, communications, and automotive IoT. Those are the three of the hotspots, along with industrial and commercial implementations. We are nowhere without software. Software and hardware together are what deliver on the promise of these workload challenges. RISC-V, again, it delivers the best processing capability for this because you can have domain-specific extensions. And this goes to the reserved encoding space where you can have vendor-specific extensions as well. By taking a modular approach, you have a base ISA with a set of extensions that you can modularly compose to only leverage the instructions that you need for your workload. This modular design leads to domain-specific extensions. And we are moving forward in crafting those into profiles and platforms to tackle the most common combinations. That's where we get into platform standardization. You'll see us investing in and rolling out compatibility and certification. You can do this today. I encourage you, if you've got a RISC-V implementation today, run it through the paces of the self-certification. Become RISC-V compatible. Let us help you. Reach out to us if you have any challenges with your test tools and how we can help you achieve that compatibility result. This is built on a contributor culture. Contributor culture means this is strategic to everyone's business, and they are enabling their staff and their resources to engage in our ecosystem, engage in the work groups, engage in upstreaming the work from the community into existing operating systems, tools, and other resources. You see some of those ecosystem organizations that we partner closely with listed here. Let's think a little bit more about specific sectors. So in automotive, as we start to scale across the entire application and compute infrastructure of the vehicle, RISC-V has a place in each one of those, whether it's autonomous or assisted driving, or some of the base functionality that has been in automotive for decades. We also enable supply chain to work together more seamlessly. By having a common set of building blocks, you avoid any of the vendor lock-in that we've seen before. That ecosystem means choice. You have choice between different providers in automotive, and we're seeing that come together already. This is bringing out nearly a third of automotive AI acceleration by 2030, as the SHD group captured as 27%. Let's look at the industry outlook. The industry outlook for data center and cloud continues to grow exponentially as well. We're looking at nearly 14% of all CPU cores by 2025. This is tremendous growth. And I will remind you, it takes several years to get to market in hardware. This means these are projects that are underway today. This is an important aspect to recognize as we look at the augmentation of existing data center workloads, whether that's acceleration in AI and machine learning, or achieving stronger performance as well as energy consumption targets. Data is growing, data centers are growing, enabling efficient computing within those cloud resources is absolutely critical. We've touched on communications. Communications is not just the phone in your hand, but it's the infrastructure that supports the new world of 5G infrastructure and wireless communications. So we see this in Android support, whether it's in a vehicle or a phone. We see this in innovation in handsets and infrastructure. And the diverse number of workloads that are in smartphones today is also captured here. This could be your Bluetooth and Wi-Fi capability in one of the dozens of chips in your phone today. Moving forward, you'll start to see the central application processing moving to RISC-V as well. IoT. This is an area that is feeding all of that data. So streamlining this instruction set means that you have more compact code in those critical, constrained environments where you need to really be efficient with code to meet those workload challenges. This is a great fit for all kinds of localized workloads that includes security as well as some of the learning and sensors that to enable compute right at the point of data ingest. This is something like running AI at the edge. These are some of the use cases that we're seeing our RISC-V community already embark on, and it's an exciting time for us to think about. This again is looking at a forecast of shipping 20 billion processors by 2028 just in IoT alone. So what about HPC? So HPC is a great new domain where we're seeing even more and more extrapolation of data to drive decision making, whether that is simulation or inference in AI. We are bringing HPC to very discrete and new workloads. Those new workload challenges may be in healthcare and life sciences. It may be in design, and we're seeing RISC-V as that custom compute that is able to meet those new workload challenges. This open ISA complements the open source software, combining to make a very open ecosystem as well. This is something that is being tackled not just in companies, but also as nations embark on their RISC-V journey. We see the European Union investing a lot of resource into HPC and leveraging RISC-V in partnerships with organizations like Barcelona Supercomputing Center. Our ecosystem is growing so fast. In fact, we see the funding Within the organization's more than $7.8 billion today, we see this at all levels. I know this is a bit of an eye chart. It is available on our website, and I encourage you to have a look. As you'll see, we have most of the major operating systems covered today, many of them already hardened in enterprise class. We see a lot of things coming forward in storage, databases, tools and resources in design, as well as applications themselves. Each one of our ecosystem partners has vested interest in running on RISC-V. They see the future, they want to participate. It's a great business decision to say, you know what, I'm participating in 3/4 of the market, let's go participate in that remaining fourth of the market because it makes business sense. And what we're hearing from the community, it's not that hard to move also onto RISC-V. Not only can you achieve parity on RISC-V, you have opportunity to fine-tune the performance and other dimensions that you can find on RISC-V because of its transparency and the performance variables. So I encourage you, if you have not already engaged in RISC-V International, think about the benefits to your organization. Think about the opportunity to elevate your industry leadership as a company, as an individual, as a professor, as a nation. Think about how you can engage in markets that are important to you, whether that's automotive or aerospace or data center or mobile. We're helping to cultivate those markets and would love to share and give visibility to your story as well. This is also a great forum where you can build your strategic network. This means build relationships with your development partners, your supply chain, your customer, and the market, and the other leading thought leaders in your space. This amplifies your visibility as well. There's no better partnership than the one where you're working shoulder to shoulder with the best and brightest in the industry. This gives you technical advantage and business advantage. So I encourage you to join us and engage in the community. Thank you again. I'm Callista Redman, CEO of RISC-V International. Please reach out to us at risc5.org or reach out to me personally on any of the social channels. And I look forward to engaging with you, seeing you in the community, and I appreciate this opportunity to share our thoughts with you today. Thank you.